won't matter.
Yeah, so let me read. To calculate the cumulative frequency, add up the frequencies of the data values as along. A cumulative frequency diagram or graph is most useful if a set of data or group data is large. Okay, so they've given you the example. 50 batteries were tested to see how long they lasted. The result in hours are shown in the table. Draw cumulative frequency diagram. So that's what we'll be doing. So we'll be drawing a cumulative frequency diagram.
Okay. What do you mean? Like, is it this?
The S-shaped graph, correct. And find the median and interquartile.
So the same thing you did here, basically.
Yeah. So how do you find the cumulative frequency? Tell me.
So to find the cumulative frequency.
So you start 3 plus 5.
Oh yeah, you take that thing.
8.
Yeah.
8 plus 8.
16.
16 plus 10.
26.
26 plus
12.
38.
Yeah. 38 plus 7 is 45. 45 plus 5 is 50. So
now you have to plot. You have to plot the upper limit versus the cumulative frequency. So you'll plot 5, 3. 5 and 3.
Yeah.
You will
10,
plot
8.
10, 8.
15,
15, 16.
20, 26.
20, 26.
25, 38.
25, 38.
30, 45.
30, 45.
And
35, 50.
Is it always the case that sometimes the first one can be larger or your first like
That doesn't all that is immaterial. All that is immaterial. So you don't have to overthink anything. So this you have to put the class interval, and here you have to put the cumulative frequency.
Yeah.
Correct? Your class interval is the time in hours, and cumulative is number, obviously. So now you plot 5, 3. So I'm just approximately quickly plotting it. 5, 3. Correct? 10, 8. 10, 8. 15, 16.
Yeah. And it always ends up as an S shape.
S shape, yeah. 20, 26. 20, 26. I made a mistake in plotting all these points. What's the mistake I made? This 2 points is 1.
What do you mean?
The 2 smaller units is 1 unit. This is
like that.
2 smaller units is 1. Because, or 1 second, let me count 1, 2, 3, 4. No, it was right. Sorry, it was right.
Okay.
So I can undo it. Okay.
Yeah.
20, 26. Tell me in the next point.
25, 38.
25, 38.
Then 30, 45.
30, 45.
Yeah. Okay.
30, 45.
Yeah. And then 35 and 50.
35 and 50.
It's not really S shape. Okay. Well, it's a very narrow S shape. It's more like a. It is, I guess.
Fine. Now you need to find a median from the graph.
So
median
what
and.
graph oh my god. There's no function given. Otherwise, I'm going to put it on my calculator and just said.
But that won't help you.
Oh, I put the list.
It will come in paper 1.
But
what's the point drawing this graph on a calculator? It won't help you at all because you are not going to attach your calculator to your exam solution. You will have to plot it on a graph paper. Then they'll give you a grade.
One question to plot.
Yeah. Now, what you need to find out is, so the point is sketching this on the calculator. I mean, it has no value. So, number of data points are 50.
Yeah.
Sigma f, this is sigma f. When you add the frequency, there's 50, and obviously this is the total of all this.
Yeah.
Because you gradually added over here. Right. When you find the median is equal to n over 2. So that's 50 over 2. That's the 25th value. Now how do you find the 25th value? You start from your 25th value. Go to this and read that.
Okay, that's a frequency. So you go, that's that particular value.
So that's 20.
20.
So 20 hours is the median.
So I remember you telling me that for the cumulative frequency graph, your formula for median is n over 2, but otherwise in general your formula for median is n plus 1 over 2.
Yeah, for discrete data it's n plus 1 over 2. Here it is n over 2. Absolutely correct. Lower quartile. is n upon fourth value.
So your fourth value is
So n over 4, 50 over 4. 50 over 4 is what?
What? I thought you look at the fourth value.
N over 4. N is the number of data points. See, whenever you have a data,
like that.
the median is n over 2. The lower quartile is n over 4, 25%, and upper quartile is 3n over 4. So you have to substitute the value of n. So in this case, the value of n is 50.
Oh. Yeah.
50 over 4 is
50
what?
over 4 is
12.5.
12.5. So how can you have the 12.5 value?
Yeah, approximately. Because it's a graph, it won't be exact. Remember, this is not an exact science, so it's okay. So you don't have to overthink
So maybe
it.
it's like 14.8.
14 I am getting
You
approximately.
can't take points, like you can't take this decimal.
How will you take decimal? A bit closer you may take it in, that's fine. But so they'll give you the range of answers.
Okay, so 14. And your upper quartile is, I don't know what.
3n over 4.
Okay, so then we see
3 into 50 over 4.
So that's 150 over 4, which is basically
37.5 value.
So
37.5 value. So you're in middle of exactly middle of this. You can go to 37.5 value.
oh, it's exact? No, it's 24.
24.
When you do 24
So
minus
interquartile range.
So 10 hours.
Q3 minus Q1.
Which is 10.
24 minus 14. Which is 10 hours. Is the interquartile range. Okay. Sometimes they will give you the graph and you have to interpret.
Okay.
So the second example, the time in minutes taken by 100 students. So 100 is your capital N, that's your total number. To reply to their friends on social media is shown as a cumulative frequency curve. Find the longest time taken to reply.
I don't understand how to find this. Wait, the time in minutes taken by 100 students to reply to their friends blah is shown. Okay. The time taken. So this is the time and this is the number of students who took lesson. What?
This is the time. They have given all your time.
Yeah. What is that?
And the number of students who took less than that time. So that means if you look at
less than that, why would you put that against that time when it's less than that?
So this is less than that. No? This is always when you sketch this. So when you do cumulative frequency, that means your 3 people, whatever this was, 3 batteries, 3 batteries lasted less than 5 hours. 8 batteries lasted less than 10 hours.
Okay.
16 batteries lasted less than 15 hours. So this is also called a less than cumulative frequency diagram.
Do we have more than also?
You also have more than, but it's not there in your curriculum.
Oh.
So if you're interested, you can come in the summer break and we can learn that.
So summer break is next year.
Yeah, next year. If you can wait to look, unless. So this is your time, and this will be less than this time. Number of batteries less than this time. So remember, this is always less than.
Yeah. Okay.
Longest time taken to reply.
So you just see the longest one. You just go to 20.
How 20? 100 is the data. 100 is the data ends here, so you can't go beyond the data. So it's 18. 18 minutes.
18 minutes. Then the median time you take from 0 to 18. No, you take from 2 to 18. Sorry.
Median time.
You take from 2 to 18, not from 2
What's
to
the formula for median? N over 2 value.
Yeah.
N is 100. 100 over 2.
I was going to do it manually. Like
50th value. You can't do it. When a graph is given to find the median, you have to use the graph.
Acha,
here they've drawn the line. If they've not drawn the line, then obviously you will have to do.
So I was not going to do that. I was going to see from 2 to 80 what's the middle value. Like,
No. You can't do that. 2 to 18, which is the middle value, because you have to also consider the number of batteries or number of, in this case, you have to look at the number of students also in this case.
Because like usually if you have like a data
set. Nothing. Whenever cumulative frequency curve is given, this is what you have to do.
Okay,
that frequency is 1 in that.
Yeah.
In all those numbers, when you arrange the numbers, assign the frequency. Here the frequency is not 1.
So is the frequency over here based on the number of students?
So 11. Yeah, obviously. Number of students who take how much long. That's the table. No?
11.
Find the interquartile range. They've already done it. So you have 25th value, correct? Which is coming here. So what is that? 8.
What do you mean you've already done it? Ah, they've already done it, sorry.
This is the lower quartile.
Yeah.
Already done. It's already
25. It's
drawn
marked.
on
It's
the
marked.
graph. It's marked already.
25. Sorry, no.
8.
Q3 is Q3 is
Q3.
14. No, like 13.
13.5 if you want to call it. It's fine. You know, they'll give you a range of
If
answers.
they said interquartile range in the number of students, that would be different.
So Q3 minus Q1. So that's what we're doing. Interquartile. You find a lower quartile, find the upper quartile, and then subtract it.
Yeah, but they're saying find the, yeah, that's correct, obviously, but they're saying find the interquartile range in time. But if they say find the interquartile range in terms of the number of students.
No, always your statistics will be from the x-axis. These are your answers. Your answer will always come from the x-axis. Yeah? Your mean, median, mode is for the time. Interquartile range is for the time. Number of students is frequency. They'll never ask you to find that. I mean, it's not. No, it's not that. It's always the timing. The time is your variable over here.
90% of the students reply in K minutes or less.
Hmm.
Find K. If it was a box, it would probably be very easy.
So, no, but we have to do what is there. 90%, box and whisker won't give you that answer.
90% of the students are 90 students.
90% of the spoons, yes, correct. 90%. So you take 90% of the total
So you
number.
see 90.
In this case, it's 100. Don't forget the step that I'm showing you. Don't ignore what I'm showing
I
you.
just did that.
That's correct, but 90, you have to take 90% of the total number.
Yeah, it just happens to be 100, so then just 90.
Yeah, it happened to be 100, definitely.
Yeah. So then
now,
you look at
90% of the students, so 90% of the students replied in K minutes or less. So this is 90%. And where does this?
So K is 16, 15.
15.5.
15.7.
15.5, 6, 7, doesn't matter.
This is pretty easy.
So 15.5 minutes.
Only drawing that graph